What is going on, guys? Welcome back to your 39th C++ tutorial, and in this tutorial we're going to be covering pass by reference with pointers, and we actually have a ton of stuff to cover, so I don't even know if I'm going to have enough time in this one tutorial. I might have to break it up into two different tutorials, but let's go ahead and get started anyways. So we already know from our last tutorials that whenever we pass an argument into a function, passing an argument into a function basically means giving our function any additional information that it needs. Like, in order to calculate the square root of a number, you actually need a number, so you have to pass a value into that function. But believe it or not, it isn't quite that simple. There are two different ways that I'm going to be teaching you right now. There are actually more than that, but for now I'm going to be teaching you two different ways to pass arguments into functions. One of them is passed by value, and one of them is passed by reference. Now, what do I mean when I say that? What we've been doing is basically passing by value, and whenever we create a function and we pass it by value, we pass a copy of that variable into the function. So the original variable itself cannot be changed until we set it equal to another value. So that way the function only has access to the copy of that variable, not the original variable itself. Simple enough. Values pretty much mean passing in a copy. Okay. Now pass by reference means this. Whenever you pass in a variable by reference, you pass in the variable's address. And whenever you do that, you basically give the function direct access to that variable. So in that sense, the original variable can indeed be modified inside your function. So why would you ever want to do that? It seems kind of dangerous. Well, the one benefit is this, is it's basically less stress on your computer. Instead of passing by value where every time you call that function it has to make a copy of the variable, suppose you had 100 variables, that would be pretty stressful on your computer. If you pass by reference and you pass in the value itself, it doesn't have to make copies of every variable. So let's go ahead and let me start off by making two variables, int Betty, and I'll set this equal to 13. And let's make another person, int Sandy, and set this equal to 13 too. Now what we're going to be doing is passing this one in by value and passing this one in by reference and see how they turn out. So we're going to be needing to create two different functions. First, let's go ahead and create a function that we're familiar with, pass by value. So void pass by value, and let's just go ahead and create a basic function. It'll take a parameter of one integer, and what we're going to do is take this integer and set it equal to 99. So basically what we're going to be doing is Betty, pretty much x is a copy of the variable Betty. So then whenever we set x equal to 99, it doesn't set Betty equal to 99, it just sets this copy equal to 99. So that's what's going to happen. Now let's go ahead and make a function pass by reference. So void pass by reference. Hopefully I spelled that right. There are way too many e's in reference. 4 e's. I mean, come on guys, enough of these. So functions that receive a memory address, they need to have a pointer argument because they need to have a pointer because a pointer is the thing that receives the memory address. So now instead of int x, you need to type int pointer x because the pointer x is now going to be able to hold that memory address. So now whenever, whoa, one little extra thing there. So now what we can do is something like this. Pointer x is equal to 66 or something like that. So now instead of the copy of x being equal to 99, now the variable itself, Sandy, x is the address of Sandy, so Sandy is going to be changed to 66. So whenever we pass Betty in this one, her value is not going to be changed. But whenever we pass Sandy into this, we're basically passing in Sandy directly into this function, her address and everything. So now this is a direct access to the variable Sandy. So let me go ahead and first of all we need to prototype these functions. So copy this and paste. Did I copy it or did I just do something weird? I might have had an extra character somewhere. Better not get an error or else I'm going to be ticked off. So copy that and then copy this reference and paste this in. And now check it out. Before we go ahead and, well, let's go ahead and just use these right now. and then I'll talk to you guys about the thing I was gonna. So let's go ahead and pass by value, and we will pass Betty into this one. So we're going to pass 13 in that, but her value isn't going to be changed. Now let's go ahead and pass by reference Sandy, and we're pretty much giving this function direct access to Sandy, so that value is going to be changed. So now what we need to do is, here's what I'm going to talk to you guys about. Since we're passing in the memory address, of course you remember from the last tutorial, we need the ampersand because Sandy is the variable, and this function takes a memory address. So the symbol for the memory address of the variable is ampersand Sandy. This is basically equal to some long hexadecimal address of where that variable is located on your computer. So now let's just go ahead and print out the values and see what we get. Cout Betty is now, and then just go ahead and print Betty and end line. And now do the same thing for Sandy is now Sandy end line. So let's go ahead and run this, and I guess I can see if I messed it up anywhere. Nope, looks good. So as you can see, we basically built identical functions. However, when we passed in Betty, it stayed 13, and when we passed in Sandy, even though it was 13, it changed it to 66. So now you can see, whenever we pass, let me move this down right here. Whenever we pass a variable into a function, we can do it in one of two different ways. We can pass a copy of it like we did in the Betty case, pass by value, and what this does is it basically makes X is a copy of Betty. It doesn't have any access to Betty itself. It's just a variable with the same value. So then we set X equal to 99. It's just setting 99 equal to that copy, not Betty itself. So if we pass by reference, what we do is we take the memory address of that variable, and remember, your memory address is some part on your computer. It doesn't make a copy of it. It passes in that memory address itself. That memory address has the value of 13, and we're saying, alright, now take that memory address and set it equal to 66. So no copies involved here. It's taking that same address the entire time and changing the value of it. So now you can see the difference of whenever we use a function like this, it makes a copy, and whenever we use a function like this, it works with the direct variable itself. So that way, whenever we ran the two functions right here and printed it out on the screen, that's why Betty stayed the same, because that copy had no effect on the original, and Sandy changed because it did indeed change the value of that one address. That variable was only at one address, and we passed it in so it had direct access to it. So I am out of breath, and hopefully you guys understand at least the concept of pass by value and pass by reference. Just remember, when passing by value, you're passing in a copy. When passing in reference, you're passing in the variable's address. If you understand that, you're good to go, at least for now. So in the next tutorial, I'm afraid we're not done. Oh, I got like phlegm in my throat. I can't talk. I just had a milkshake from McDonald's, and anyways, moving on. So in the next tutorial, unfortunately, we're not done covering pointers yet. So yep, more about pointers. I'm sorry. So thank you guys for watching. Don't forget to subscribe, and I'll see you guys in the next video.